Hey knowledgeable, welcome to today's session. So today we would be talking about the factors, perfect numbers, multiples, prime numbers and composite numbers, even and odd numbers, and we will also do some question and answer. Let's try to recap division. So divisor is the number by which we divide. Dividend is number which is getting divided. Quotient is the result of the division and remainder is the leftover after the division. We can write dividend equal to divisor into quotient plus remainder. So this is what we have studied in our previous classes. So let's understand what is factor. A factor of a number is exact divisor of that number. So what is exact divisor? Exact divisor means remainder has to be 0 after division. So for example, 2 is exact divisor of 12. So you can tell 2 is a factor of 12. So let's see an example of factor. So question is basically find the factors of 12. So basically we have to find what are the numbers which are the exact divisor of 12. So we'll find that these are the numbers 1, 2, 3, 4, 6 and 12 are the factors of 12, means these are the exact divisor of 12. So if you divide 12 by these numbers, the remainder would be 0. Let's try to see different ways to find factor. We'll see method 1 with an example. Suppose I have to find the factor of 12, then start with 1, 2, 3 and so on till 6, that is half of that number, and see if the numbers are exact divisor of 12 or not. So if the numbers are exact divisor of 12, then include it in the collection of factor and include the number itself as factor of 12. So if we follow this step, then 1, 2, 3, 4, 6 and 12 will come as a factor of 12. In step 2, I had told you to go only till 6. So why I told this one? Because any number which is greater than half will not be exact divisor except the number itself. So let's take the example of 12. So half of that number is 6. If we take any number which is greater than 6, that is 7, we'll try to divide 12 by 7. So we'll find that this is not the exact divisor of 12 because there are some remainder. We can try some other example also and see if that holds true. So that is a home task for you. Try to do yourself. Now let's try to solve one question using method 1. So find the factor of 36 using method 1. So pause the video for some time and try to do yourself. The answer is there in the next slide. So when we apply method 1 to find the factor of 36, we'll find that these are the numbers which are factor of 36. That is 1, 2, 3, 4, 6, 9, 12, 18 and 36. Try to match your answer. Now we'll try to see method 2 with an example. Suppose I have to find the factor of 12. Then start writing the number as multiple of two number in different ways. So we can write 12 as 1 into 12 or 12 as 2 into 6, 12 as 3 into 4. So these are the three unique ways in which we can write 12 as multiple of two numbers. So collect all the unique numbers in multiples. Those numbers will constitute factor. So what are the unique number? So 1 is unique, 12 is unique, 2 is unique, 6 is unique, 3 is unique, 4 is unique. So basically the factor of 12 would be 1, 2, 3, 4, 6 and 12. Now let's see this question. Find the factor of 36 using method 2. So pause the video for some time and try to find the answer by yourself. The answer is there in the next slide. So let's see the answer. By applying method 2, what we can see that 36 can be written as 1 into 36, 2 into 18, 3 into 12, 4 into 9 or 6 into 6. So what are the unique multiple here? So you will see that these numbers are the unique multiple. So this will constitute the factors of 36. So let's see some of the observations on factor. So one is factor of every number. every number is factor of itself. Every factor of number is exact divisor of the number, that is by definition. Every factor is less than or equal to given number. So let's see the factor of 12. So factor of 12 are 1, 2, 3, 4, 6 and 12. So if you see all the numbers or all the factor is less than or equal to the number itself. Then the last one is number of factor of a given number are finite. Means you can count the number of factors for a given number. So if you see how many factors are there? There are 6 factors. So let's see what's a perfect number. A number for which sum of all its factors is equal to twice the number is called a perfect number. So if you see example of 28, so what are the factors? So here are the factors. If you sum all the factors, then it comes around 56. So that is double the number 28. So we can call 28 as a perfect number. So check if 6 is a perfect number or not. So this is a homework for you. So let's try to understand multiples. So let's see some examples. So multiples of 3 are 3, 6, 9, 12, 15 and so on. So multiples of 4 are 4, 8, 12, 16, 20, 24 and so on. So let's see the observation on multiples. So every multiple of a number is equal to or greater than that number. So if you see multiples of 3 are 3, 6, 9, 12 and so on. So if you see all the multiples are either equal to this number or greater than this number. The multiples of a given number is infinite, means there is no end to how many multiples it can have, and you will not be able to count on the fingertip. So every number is a multiple of itself. So for 3 is its multiple. We can also say that number is multiple of each of its factor. So if you talk about 20, right? So 20 is multiple of each of its factors. So for 4 and 5, 20 can be considered as a multiple, because if you see multiple of 4, right? So it will be 4, 8, 12, 16 and 20 and so on. So 20 is one of the multiple of 4. In the same way, if you see for 5, so it will be 5, 10, 15, 20 and so on. So 20 is a multiple of 5. So let's see what are prime numbers. The numbers having exactly 2 factors, that is 1 and the number itself, are called prime numbers. So let's try to see which numbers from 1 to 12 are prime. So let's see the table below. So this column tells about the number. This column tells about the factors of that number. This column tells about the number of factors for that number. So as per definition, the prime number should have exactly 2 factors. So let's see which numbers are the prime number. So if you see 2 is the prime number, 3 is the prime number, 5 is the prime number, 7 is the prime number and 11 is the prime number. So let's see this question. What this question tells: find the prime number between 1 to 100. So we will apply the same rule as we have done in the previous slide to get the answer. Answer is given in the next slide. You can do it by yourself and then check the answer in the next slide. So here is the answer. All the number which has been marked with purple, so those are prime numbers. So let's see what are composite numbers. The numbers having more than 2 factors are called composite numbers. So we have seen this table previously also in the case of prime numbers. So here we'll try to see what are the numbers having more than 2 factors. So those will be composite numbers. So if you see 4 is a composite number, 6 is a composite number, 8 is a composite number, 9 is a composite number, 10 is a composite number and 12 is also a composite number. So let's see what are coprime number. Two numbers having only 1 as a common factor are called coprime numbers. So for example, if you see 4 and 15, so let's try to find the factor of 4. So factor of 4 are 1, 2 and 4. Let's see the factor of 15. So the factor of 15 are 1, 3, 5 and 15. So if you see here, only 1 is the common factor between these two. So we can tell 4 and 15 are coprime numbers. So what are even numbers? The numbers which are multiple of 2 are called even number. So here if you see 2, 4, 6, 8, 10 and so on are called even numbers. What are odd numbers? The numbers other than even numbers are called odd numbers. So if you see 1, 3, 5, 7, so these numbers are not divisible by 2. So these are odd numbers. So some more observations on numbers. So 2 is the smallest prime number which is even. Every prime number except 2 is odd. So after going through the different type of numbers and their properties, let's try to solve some of the questions. So here we have some questions where we have to mark true and false for each of the statement. So pause the video and try to solve this question. So we will come back with the answer and try to discuss this. So now coming to the answer. So let's see what is the first question. The sum of three odd number is even. So this is false because if you try to add 3 plus 5 plus 7, so this gives you 15. So this is not even. So sum of two odd numbers and one even number is even. So this is true. Let's take the case where no one even number we have taken as 2 and two odd number we have taken 3 and 5. If you add, then the sum would be 10, which is a even number. So I think this is true. The product of three odd numbers is odd. This is also true. So try to multiply 3 into 5 into 7. So this will give you 105. So this is odd. So I think this statement is true. So let's come to the fourth question. If an even number is divided by 2, the quotient is always odd. This is false because let's take the even number 4 and divide it by 2. So it will give you value 2. So this is not odd. Coming to the next question, all prime numbers are odd. I think this is false because 2 is not a odd number, 2 is a even number and 2 is also a prime number. Prime numbers do not have any factor. This is false. By definition, we know that the prime numbers have two factors, one and the number itself. Sum of two prime numbers is always even. This is also wrong. So suppose you take the prime number 2 plus another prime number is 3. So this will give you a 5 and this is not even. So 2 is only even prime number. This is true. All even number are composite number. This is false because if you take 2, right, that is not a composite number because it has only two factors, 1 and 2. So and that is a prime number, that is not a composite number. The product of two even number is always even. That is true because if you take 2 into 8, right, it gives you 16. So that is again an even number. So this is true. So that's about all the questions. This is what I wanted to discuss in this video. Thank you for watching this video.